we doing, guys? Good to see your faces, especially those of you that haven't been here in a while. We're going to just jump right back into things. I think I've been saying that we only had a 2-day exam review, but I went and looked. Y'all actually are the only class that will have a 3-day exam review. If you haven't started on that review packet, yes?
Can I get the review packet?
Have I not given it to any of y'all?
No.
There were a couple of y'all? Okay. Who needs one?
I got Mary to get it for me last week.
And if y'all need another one,
Oh, this is calculus.
dadgummit. Let me get those back. You probably don't want the calculus. I'm glad you just looked. That would have probably blown your mind. So, wrong class there.
Oh, stop.
Let's try that again. Two. Yeah, and if y'all want another one of these, just give me a heads up and I'll try to get kind of a final count. I don't like to print ones that end up getting wasted, but I'm happy to do that. It'll save your printer ribbon at home. But again, I'll just as a reminder, you guys are going to get a little bit of a gift this year, in the sense that they've asked us to kind of be a little kinder on these exams. So I actually have already gone through and done yours and looked through there, and a lot of the problems that traditionally people have missed, I have either gotten rid of or softened the part that made it real tricky. And if your question is, well, what do I need to study for? Again, every problem on your exam came from this packet. Every one. So if you know what's in this packet, you know your exam. The issue is, can you learn what's in that packet well enough to be okay? And I think you can. People every year, I have people that have like 77 averages, and they're like, man, I'm entrenched in a C. I can't even get a B. Yes, you can. Now, you might need a 90 on this exam. Actually, you don't need that. You need an 8. You would need an 87 on this exam to pull a 77 to a B for the semester. But I see people do that all the time, even in normal circumstances where this test would be a little more difficult. Okay? So now they might have to do this review sheet a couple times, and a lot of people do. They do it once, they check it, correct it with like red pen, and then they get another copy and they redo everything they missed, right? Because you figure if you got it right the first time, you're probably in good shape. And then they check it and correct those and then redo those again. You're putting yourself in a great position to do really well. Now, if you need a 60 to keep your B or a 50 to keep your A or whatever, I can understand maybe not worrying about it as much, but be careful, because every year I have somebody who does need like a 73 to keep their A, and they make a 68 on it. Don't be that guy. That's not going to happen to you if you really care to study. And also, if you're discouraged at any level, like, yeah, but the material's so hard, if you start reviewing and start doing this packet, you're going to see the problems on there are not the same level of difficulty that I've been testing you on all year. It's more of a middle-of-the-road kind of thing. I really do. In the past, I have used this as kind of a gift to you. It's more of a regular Algebra 2 level exam, and I'm giving you all the answers. I'm just giving you an excess of other answers. You just got to be able to know everything. Y'all with me? And as a reminder, if you're feeling like, oh, this is so long, I think it goes through page 24, but they're probably, the first 4 pages don't even have problems on them. I think there's some backsides in there that don't, and all my other reviews are 30-something pages. So yours is actually fairly small comparatively this semester. So anyway, be hopeful with that and do the best you can on it. And I think you can finish this year strongly. Even if you do have like, crap, I got a C for the semester, I've never made a C in my life. You don't have to finish that way. I mean, you can get this up and actually make some positive damage. Okay? All right, so what you should know right now is arithmetic and geometric sequences and what they are. And that's more than just knowing the formulas, but if you don't know the formulas at this point, you really need to make sure you do. And that probably is because it's been a long break, or maybe you just haven't been doing the homework problems, or maybe you've been doing some copying of the homework problems. Make sure you know these. Who can give me the arithmetic formulas we know right now?
2
to find a term.
F for n equals
T1.
T sub 1
T
or
sub 1 plus
T sub m, right? Plus
rate times
plus
N plus 1.
parentheses
and minus 1 times
n minus 1
times rate.
times the common difference,
Or difference. Yeah.
right? Or here, n minus m times the common difference. And then we also said to find the common difference, that's kind of like our slope. And you don't have to memorize this, because if you know this, right here, how do you solve for d? Subtract the m, so term minus term, divide by that, place minus place. Just make sure that that term in that place, whatever you have comes first, and that term with that place comes second. You can switch these, but don't just switch one without switching the other. You with me? And that's for arithmetic, and then what do we know about geometry? So T of n, T1 or T m times the ratio to the power of either n minus 1 or n minus m. And then what do we say about the ratio formula here? Again, you can plug it in here and just solve for r, but I found it kind of helpful to know this. To solve for r here, what would you have to do? So you have to divide by that term, so term over term, and then once you divided by it, how would you get the r by itself? You'd radical or root whatever that expression was. So you end up doing the root of whatever n minus m is, and that gives you r. But what do you have to remember about that? Awesome. If that's even, right there, then you have to insert a plus or a minus. If it's not even, then just leave it positive if it's positive, or leave it negative if it's negative. And if you have this down right now, you're probably in decent shape. Although it's very easy to pick random problems that can trip you up. But again, nothing shows up on your test that hasn't shown up on a homework problem. So if you're doing all those homework problems, again, if you've skipped any, you might want to go back and just come visit me. I got a kid in my calculus class. He is probably the only one who comes into my class with regularity. He is easily one of the top 3, maybe the best calculus student I have. Should have taken BC Cal, but just didn't want to. And so he's in here. I call him bored to tears because all his test scores are 95s to 100s consistently. But he's the one who comes to ask questions. And it takes him literally, he goes, hey, I got a question for you. Throws it up on the board, gets it answered, walks out. It really doesn't take that long if you have issues. Just come in here daily. Just walk. I know you don't get here to your parents or siblings or whatever, most of you, you're kind of at their mercy, but just hop in, ask a question, hop out. Really doesn't take any effort for you. Certainly I'm willing to, and it would help with those, because those are the problems that show up on your test. Are y'all with me? Okay, what I'm going to talk about tomorrow is sums of these sequences. So these sequences, we haven't been adding anything together. We've just been finding certain terms or certain places or how many terms are in a sequence, and we've been doing it all through these formulas right here, right? What if I asked you to sum them all? That would be different, because now instead of just finding the 100th term, I want you to add them all together. Well, those are formulas we're going to attack tomorrow, but today I want to give you this notation that we use that I'm guessing you may have seen, but I don't know because COVID changed what Helmers did with you last year, so you may not have gotten this. But there's this thing called sigma notation. Does that ring a bell at all?
Is that like the E looking thing? Looks like an E?
Yeah, this sigma notation, sigma, it's a letter in the Greek alphabet. There's 2. There's a lowercase sigma that looks kind of like that, and there's an uppercase sigma that looks like this. Okay? We use the uppercase sigma, but it's actually a Greek S, is what that is. So you might have had a dad who was an SAE in college or something like that, but sigma, alpha, that was the sigma part of their Greek letters. And we are going to use that expression And what this expression means is, when you see that, it means the sum of. Okay? Now the way you're going to see it, you're going to have this big sigma right here. Maybe not big actually, but you're going to have this sigma. Okay? Kind of looks something like this. And the way you're going to see it is you're going to have some formula right here to the right of it. And I'm going to write formula for the nth term. Now, if you think about it, those are the formulas that we've just wrote on the board. Those are my Tn formulas. Except we don't write Tn equals, we just write the actual formula. So if Tn was 3n minus 6, we just put 3n minus 6. We don't write Tn equals 3n minus 6. You all with me? If the formula was 5 times 2 to the x minus 3 power, then we're just going to write 5 times 2 to the, or n minus 3 power. So the formula goes there, and that will tell the reader of this which expression or which sequence that we're actually working with do we want to add those terms up, because this means the sum of the terms in the sequence. All right? Now, sequences might begin on the first term, they might begin on the 10th term, they might begin on the 100th term, they might end on the 5th or the 100th or the 1000th. That's what I'm going to do above and below. Below, I'm going to tell you what place you want to start with. So below you're going to have n equals, and there's going to be some number. The number right there is the place of the initial term. Now when you hear the word initial, most people think first term. All right? Is everybody with me so far? But our initial term might be like the 5th term. Like for instance, if I wrote out the even numbers, 2, 4, 6, 8, 10, all the way through 100, I might not want you to add all of them. I might say, well, I don't want you to start with the first term, the T1. I want you to start with the 10th term, which is like 20. So I might say n equals 20. And that will tell you, okay, don't start with the 2 or the 4 or the 6 or whatever. Or I'm sorry, the 10th term. I would write n equals 10. So that would be the place, not the term, but the place of the initial term. And I'll give you some examples, you know what I'm talking about. Now on the top, I'm going to write the place of the last term that I'm going to be adding. Except I don't write n equals. So you'll just see a number up top. And I don't know why they don't write n equals. I guess they just wrote it once just to let you know that was the variable in question here. And we're going to use n all the time, but some books use I. Math tournaments love to use I because people that aren't really on their game think of I as an imaginary number. But if it's in the context of something like this, whatever variable, that stands for the place. But I'll use n or j sometimes, but mostly n, starting out in algebra 2. Now, this right here is called sigma notation. This doesn't add for you. It doesn't. It's just another way of writing something. Okay? So if I wrote it like this, you should look at this and say, this means for you to add, find the sum of all the terms that are in that sequence that will be written right here from this place to that place. But today we're not going to learn how to do that. We're just going to learn how to write it this way and some of the issues people come into contact with here. And then hopefully tomorrow, when I give you one of these, you'll go, oh, now I can find the sum because I'm going to learn some formulas tomorrow. Got with me so far? Okay, so for example, here's what you might see on a test. I might say, well, let's start basic. I might say expand this expression. Expand being the key word. And let's just say I wrote sigma n equals 4 to 15, 3n minus 6. Now technically, if all you saw was this expression and there were no words, what would it mean to you?
Would you like plug in numbers 4 to 15?
That's what I'll do, but what does it mean to you? Like, it means find the sum of all these things, right? Because this means find the sum of all the terms that show up in that sequence from when n is 4 to when n is 15. Now, how would you do that?
You plug in every number and add them up.
You plug in every number from 4 to 15 in there, and then add them up. That's what this is telling you to do, this expression. But if I say the word expand, it doesn't mean to add them up, it just means to write them out. With pluses, because sigma notation means plus. So, I plug a 4 in, and I start with the 4. And what happens if I plug a 4 in there? I get 6. And then because sigma means add, I go plus. Then what I plug in? A 5, and when I plug a 5 in there, I get 9. And then I plug a 6 in there, and I get 12. Now, I really don't want to plug the 7, the 8, the 9, the 10, the 11, 12, all the way through 15. That's boring to me. And it's pretty clear now, what have we established?
There's patterns.
There's a pattern. So after 3 of them, I see the pattern. I'm just going to go plus, dot, 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 plus, and skip all the way to the last one. I'm going to plug 15 in there and get 45 minus 6. Now, if there were only like 5 or 6 terms, I might write them all out. But in something like this, there's a whole bunch of terms, right? Well, I don't want to write them all out. And a lot of times the number on the top is like 200. I certainly don't want to write all those terms out. So always write the first 3. Now don't put commas. If I put commas, what are you not showing me?
Addition.
Which means you don't know what sigma means. Because sigma means add them up. Now, if I didn't say expand, and on your test, you see this, then you would need to add these up. And tomorrow we're going to learn a formula for that, and it's pretty easy. It's pretty easy for you to even come up with it and see where it comes from. It's not like this formula that's hard to memorize. You're going to look at it and go, oh yeah, it makes sense. All right, because we'll talk about it. But anyway, today, I'm just going to want you, if it says expand or write out the expression, you're just going to write out what it would mean. Are y'all with me so far? All right, another way I could ask a question about this is, I might not say expand the expression, I might say, how many terms are in this expression? Now there's an easy way and a hard way, okay? Here's the hard way. The hard way would be to actually write out what you just did again, right? 6, 9, 12, all the way through 39. And then to look at this and go, oh, well, it's arithmetic. I could pull out my arithmetic formula, right? And what would I be looking for here?
First term, or the first term, the initial term and the lesser.
What am I looking for if I want how many terms?
Well, you know that M is 6, right?
Well, here's the problem.
How you look?
I normally, when I'm looking for how many terms, I'm looking for n, the place of the last one. But when I did that, again, this is the hard way. There's a much easier way. When I did that, I was always kind of thinking about this as my what?
That's your first.
As my first. Technically, this is my fourth. But I guess I could, again, this is the hard way, I could look at this and go, you know what, I'm just going to rethink about this as T1, and then I could rethink about that as Tn, and then I could just use this formula and solve for the place of the last one. Now, a lot of you right now might be thinking, oh, well, if that's the case, why don't, if this is N4, N1, if I decrease that by 3, I could just decrease that by 3 and get 12, couldn't I? And say there's 12 terms? Or if you didn't think that, couldn't you now just plug 39 in here, 6 in there? You can see the common difference is 3, and you can subtract, divide by 3, and add a 1. And you could say, oh, there's 12 terms. But to me, this is super hard and not necessary. Because what I would do is think like this. I'm going to come back to this one. If I gave you this sigma notation problem,
Wait a minute.
what am I going to say? How many terms are there? How do you know there's 100?
Says 100 on top.
How many terms are here?
15.
No, they're not. There's 12. We just found out there's 12. So the whole thing about the number being on the top doesn't work.
You subtract one.
You can. She said I could subtract one and add one. How about this? Think like this for a second. Here, I'm starting with the first term, right? The place of the first term is 1. The place of the last term is 100. That's pretty easy to see that there are 100 terms, right? Did I subtract anything there?
No.
No. 1 to 100, 100 terms. But 4 to 15, clearly I didn't begin with the first term, did I?
No.
So even though I might have ended in the 15th place, that doesn't mean there were 15 terms because I didn't start in the first place. So which places did I leave off if I started in the 4th?
1, 2, 3.
1, 2, and 3. So if I leave off the first 3 terms, they were never included, then I could just say, well, therefore, 15 minus the 3, right, that I left off, means there's 12 terms. How many did I leave off here? None. I started with the first one. So that's why 100 terms. Now, if you're looking at this and saying, well, when do you have to do this and when do you write it out? Well, that has to do with the question. If the question said how many terms, just tell me how many terms there were. That number minus whatever I left off. But don't go 15 minus 4, because I didn't leave off the 4th term. I included it, didn't I? And then here, if I start with 1, then of course it's where I ended up, right? I ended up in the 100th place. I started in the first place. So what if this was like a 12 right there? Right, it's 89, not 88, because which terms did I leave off? 1 through 11. So if I leave off 11 terms, take the last place, subtract that, there must be 89 terms there. Y'all seeing that? So those are 2 of the things that I could ask you on this homework tonight, but the biggest one you're probably going to see on your homework is something like this. And it's going to require you to understand this right here. So what if I said, write this series, and by the way, the only difference between a sequence and a series is the sequences we have are just lists of numbers. The second I take away those commas and put pluses in there, it turns into a series. That's all, or a summation, but most people call them series. So, like this is what I would have written earlier, 2, 5, 8, ... I don't know, let's just say, I'll just say ... You can clearly see this as an arithmetic sequence, right? Well, today, I'm going to change that to 2 plus 5 plus 8 plus ... So, if the question was, write this series using sigma notation, what do you need?
You need the formula,
I need the formula for the nth term.
and you need the last, or how many terms there are, the top one.
I need more than how many terms. I need the place of the first one
Oh, yeah.
and the place of the last one. Then you may go, there isn't a last one. We'll get to that in a second. So the formula, you have to first decide, well, what formula do I use? The arithmetic or geometric formula? Arithmetic, because you can see that it's arithmetic, right? So I'm going to go, all right, what is my formula for this particular expression? How would you do it? T1, which is 2, plus n minus 1 times common difference, which is 3, and when I clean that up, I get 3n minus 1. So if that's my formula, that is what goes in my sigma notation. 3n minus 1. And by the way, make sure you put those in parentheses if it's arithmetic. If it's geometric, because it's all multiplied together, it's not necessary. Although you could still do it if you wanted. But here, if I do, look at the difference. If I do this, then what it really looks like is I'm taking the sum of this sequence, and when I'm finished, I'm subtracting 1 from it. As opposed to taking the sum of all of it. I want that to be my sequence, not just the 3n part. Okay? So make sure on the arithmetic you put parentheses. All right, now what else do I need? I need the place of this one. Now, did anybody tell you what place that was in? So what would be the easiest thing to do then? Just to call it the what? The first place? Great. N equals 1. Now, what place is the last term in?
Infinity.
Yeah, if there is no last place, then you just put an infinity up there to show that the sum was going forever. Y'all with me on that? Now, I want to put a place in there, so here's what I'm going to do. I'm going to put plus 311. Now what goes on the top?
311.
Really?
No.
Does the term go there or the place of the last term?
Place.
Okay, so if the place of that goes, then I need to find out what place that is sitting in. Because it's not in the 311th place. That would only be true if I was going like 1 plus 2 plus 3 plus 4, and I was going through every single term. I'm skipping, right? So how do I figure out the place? Well, I go back to my arithmetic formula, right? The place of the last term is the same thing as how many terms. So can't I do that? That number right here, I can say, well, and by the way, you can use this. You've already found the formula, right? So take that and put it there, and then just borrow this equation and plug the 311 in there. You've already done the math, right? So you can use it twice. You can use it for the formula, then you can add 1 and divide by 3. And then the 104 goes right there. Y'all seeing this? But make sure you use that equation, guys, before you go and plug the 311 in there. Don't plug 311 in there and then subtract that, right, 3n minus 312 or something like that. Don't do that. Once you get the formula, write it down, then use that formula to find what place it goes up top. Not too bad? Now, here's the annoying part. When you go to your homework tonight, you're going to have this as an answer, for example. And then you're going to get to your homework and you're going to see stuff like this. How about you're going to see that. And you're going to go, what the heck? But doesn't it still work? Think about it. If I plug a 0 in there, what do I get? If I plug a 1 in there, what do I get?
5.
If I plug a 2 in there, what do I get? 8. And if I plug 103 in there, what do I get? 311. So it still worked. That doesn't mean you're wrong. It just means they used a different process. But our process, we're going to use what we already know. So if you write something that's true, don't worry about it. If you write something that actually doesn't work, you might want to check. If you think you're wrong, check. If I plug a 1 in there, I get a 2. If I plug a 104 in there, I get a 311. If I plug a 2 in there, I get a 5. Okay, now I'm right. That's just another option. So don't be bothered by that tonight. They do that a good bit on this, and people always come in the next morning thinking they did everything wrong. It's not the case. Y'all with me? All right, what about this? What about this? Oh, start small. So write this series, and again, it's a series because I have the pluses in there. Write it using sigma notation. And you might go, this is stupid. I'm not going to argue with you there. I mean, not because I don't want to argue, because I kind of agree with you. Why would we do all this work to write something in sigma notation when it actually makes pretty good sense right here, right? I mean, doesn't take a whole lot of extra letterage or numbers or whatever than it does writing this. And it's really clear here that it's geometric, right? Times 2 times 2. Whereas this one, you might have to think a little bit more. This is great, but you're going to get asked this, so make sure you're good with it. It's not overly difficult. So what do I need to put this in sigma notation?
The formula,
The formula for the first term, that's a great place to start.
the last term,
So what kind of sequence is it? And I do need,
Geometric, we know it's geometric.
it's geometric, right? And I don't need the last term, but I would need the place of the first and the last,
The place, yeah.
right? So I need the term, and you know it's geometric, so let's get started. What's your formula? Tn equals-
Equals 5 times.
Okay, so Tn equals 5, which is your first term, times, you can clearly see the common ratio is a positive 2 to the n minus 1. There's your formula, go ahead and use it. So, sigma notation. And for those of you right now who are making terrible looking sigmas, here's a, because I see this all the time for sigma. Okay, if you're making bad sigmas, the easiest way to correct it is just concentrating on making the two top things parallel. Because if you make the top part and the bottom part parallel, instantly you've got a better looking sigma. You just focus on making those parallel or horizontal. All right, so that goes right here. And you remember on geometrics, you don't need to put parentheses around the whole thing. That's just an arithmetic thing. And remember, don't write Tn equals, just write your formula. Now what do I need?
The place of the first and last term.
Okay, so since nobody really said what place they're in, we're just gonna call that what? N equals 1. Now the book doesn't always do that. Sometimes they say n equals 3, n equals 2. Don't worry about what they do, you just worry about you. So I'm gonna call that the first term, so n equals 1. But I do need to figure out what place that's in, because I don't want to put 10 to 40 right here. That's not the place. That's the actual term itself. So how do I do that?
Formula.
Use the formula you already have, but make sure you enter that formula in before you start using it, or it'll start becoming corrupted. So 10 to 40, plug it in there, and essentially what am I finding here? I'm finding what place that's in, which is how many terms there are in this case. And how would you solve that thing?
Divide by 5.
I divide by 5, and when I do that, I get 2,048. And then, oh my gosh, I know powers. And even if that power was higher than what I knew, I know this has to be a multiple of 2. And why do I know that?
It's even.
Because n's a whole number. And it has to be because it's a place, right? I can't be in the 1.5 place or something like that. So because I recognize this is 2 to the 11th, I can use my 1-to-1 property, or I can log base 2 both sides, and then when I add the 1, I get 12, and 12 goes back right there. So you might look at this and go, man, I did all this work to write something that actually looks uglier than it did before. I will concur that that probably is true for a lot of people, but this would be writing it in sigma notation. And again, there's a very strong likelihood that when you do this and you check your work, they have this. But does it give you the same thing? Try it. If I plug a 0 in there, I get 5 times 2 to the 0, which is 5 times 1. If I plug a 1 in there, I get 5 times 2. If I plug a 2 in there, I get 5 times 4. It still works. And if I plug an 11 in there, I get 5 times 20, 48, which is 10 to 40. Y'all seeing this? These are just examples of sigma notation. Mine are going to look like this because I just want to start with that. But a lot of times theirs is going to look totally different. I mean, sometimes really, really different. Like just to mess with you, I think. Are we good so far? Yes? All right. Let me throw a curveball at you. Right? Using sigma notation. So what do we got here? Yes, a little bit of a curveball in that what? This is not an arithmetic sequence, is it?
No.
And it's not a geometric sequence. In fact, what does it really look like?
Just a random.
An arithmetic on the top and a geometric on the bottom. So you can see what's happening, right? And sigma notation is just a way of describing what's happening. So why don't we give it a shot? If I'm looking at this, I basically have an arithmetic sequence on the top where that's the first term, and a geometric on the bottom where that's the first term. Well, couldn't you kind of think of your formula like that then? And say, I'm just going to put an arithmetic formula on the top. Now, how would I do that?
N plus 2 on the top. And
So I could go to my arithmetic formula, which this might be a little bit of an overkill, and say my first term is 3, my common difference is 1, and I get n plus 2 as my formula, right?
yeah.
So n plus 2 on the top. And if you don't need a formula, that to do this, that's fine. And then what would my formula on the bottom be?
3, 2 times 3 to the n minus 1.
So first term is 2, ratio is 3. All right? So that's the formula for the bottom part. Am I allowed to write that as 6 to the n minus 1?
No.
No. And then in both of these, wasn't I referring that to the first term
Yes.
when I use my formula? Great, then you can write n equals 1. Now I've got a little bit of a hint. I could, if I wanted to find what place. It should be true for both, right? The place of this and the place of that should work out, but to me the place of this one's going to be a little easier to find. So I'm just going to use 16 as my final term, and if I do that, how many places do I have?
14.
Now I could do the same thing over here and go and do that. I'll eventually get the same thing. Is that my phone blowing up?
I don't think so.
Okay,
Might be mine.
no worries. So 14. Y'all seeing this? And you will see some uglier ones on there. You will. Like I'm going to show you a really ugly one that you might see. I'm going to show you two, and then I'm going to see if you can think through it. All right. What about this? And the question again is, write using sigma notation. So what's going on here?
It's
Arithmetic or geometric or something else?
It's like a negative and it's like geometric, but there's like a negative.
Okay, you see the signs changing and you immediately think geometric. Hold on to that thought because I'm about to throw it on its head, but at this point it is definitely a ratio of -1/2. How do I know that? Because if I put that over that, I get a -1/2. That over that, I get a -1/2, right? So if that's my ratio, what would my formula be? 48
times -1/2 to the n minus 1 power.
n minus 1. You'd be shocked how ugly I can write my sigma notation using this right here. So do not be, when you look at these answers, again, your answer might be great. As long as it's creating the right formula, double check that, you're good. It does not have to look like this book's work. They intentionally are trying to sabotage you. Don't let that happen, okay? They're just trying to make you feel like you're small or doing something wrong. I don't know, have any idea why they're doing it either. Are we good right now? So here's my sigma notation. You don't have to do any simplifying of this. Now, I'm assuming that that would be the
First term.
first place, so n equals 1, and what's the last place? So if it goes forever, how many places?
Infinite.
And I'm just going to put an infinity up there. Are we good? All right, here's the one that tends to mess people up. And again, the directions are right using sigma notation. Now, what's weird about this thing? In your own eyes, what do you see?
It goes back to 10. We don't see why.
What do you mean it goes back to 10?
It looks like it's adding 10, but the signs are switching.
Yeah, like if you combine 10 and 20, that's gonna get you negative 10, plus 30 is 10, minus 40 back down to 30, plus 50 is 10, and then it just goes like that, keep going back to 10.
Well, if this is negative 10 and 30, it gets me to 20.
Oh, never mind.
But
It's just
he said it looks arithmetic except for the signs, right? 10, 20, 30, 40, 50, 60, all the way to 470. But the signs messing me up. So what makes the signs change?
Well, it's actually
That's why I think it's.
And it's not geometric, because geometric would mean I would have a common ratio. And if I put that over that, I get a negative 2. But if I put that over that, I get a negative 3 halves.
Wait, is it just because but, I have no idea.
It's kind of like both, but neither. But again, I'm not having to, if I wanted to find a certain term, like if I told you I need to know what place that's in, isn't that going to be in the same place, whether they alternate signs or whether they're all the same?
Yeah.
Right? So couldn't I just pretend that they're all pluses and then figure out what place that's in? So getting that spot, that thing's not going to be a big issue, is it? And I know I'm going to start with n equals 1 because I'm going to call that the first term. The issue is my formula. Well, how about this? What if I just pretended in a situation like this that it's arithmetic? Right? What if I just said, I'm going to pretend that it's 10, 20, 30, all the way through 470. What would my formula be now? What would it be?
Plus
First term,
10 plus
n minus 1 times the common difference of
10.
10, and that would give me 10n.
Yeah.
What if I did that and said, all right, I'm going to use 10n for my formula? Now the problem with that is, I could definitely plug n equals 1 in there. Once I've used my formula, I can definitely find what? The place of the last term. The only problem I have is, this formula doesn't work all the time. Does it? If I plug a 1 in, it works. If I plug a 3 in, it works. If I plug a 5 in, it works. And if I plug a 47 in, it works. But it doesn't work the rest of the time. Well, what made these signs switch? The negative? Let me ask you a question. I put the negative on my ratio because I was always multiplying by a ratio, right? Would this still be true if I did this? Think about it.
Yeah.
If I plug in 1 in there, I get 48. If I plug a 2 in there, I get positive 24. But wait, if I plug a 2 in there, it changes the sign. If I plug a 3 in there, I get 12. If I plug a 3 in there, that's positive, so it didn't affect my 12, does it? So really, when you do a ratio and you make it negative, it could have been written like this. And the reason why writing it like this is helpful to think is, couldn't I also just say, hey, if I want the signs to change, I could just multiply this by -1 to a power. Now the power is up to you. Make sure it works. If I plug a 1 in there now, I get the 10. What is -1 to the 1 minus 1? -1 to the 0, so it's 1. So is my answer 10 good? Great. Now what happens when I plug a 2 in? I get 20. But what does a 2 in there give me? negative 1 to the first, which is a negative 1. Will that change the sign like I want it? Yeah. So even with an arithmetic looking one, if you want the signs to change, multiply by a negative 1. Now be careful that the power, you're either going to have an n up top or an n minus 1 up top. Let me show you the difference. What if I started with this? Negative, positive, negative, positive, negative, positive, negative. Right? Now this doesn't work, does it? So I could just throw off that. Now does it work? If I plug a 1 in there, there's the 10 part. 1 in there, what's negative 1 to the first? Negative 1, negative 1 times 10 is a negative 10. If I plug a 2 in there, what's negative 1 squared? Positive, so I'm just left with the positive 20. So if you ever want the signs to change, it's easy on a geometric because you just include the negative with the ratio. But on an arithmetic looking one, you don't have a ratio. So if you want the signs to change, you can still multiply by a negative 1 to any power and just make sure it works. And you can make it work by changing that to an n minus 1 or an n plus 1 or an n. That part's up to you. Does that make sense? Yes, no? You're going to see some other ones that are a little bit ugly too. Like you might see this. And just use your best ability. Okay? I'm not going to do a lot of this on your test, but you're going to see something like I'll see it. Oh, right in sigma notation. Right.
Plus 5, plus 7, plus 9.
I am going plus 5, plus 7, plus 9, plus 11. That's not arithmetic though, is it? Arithmetic would be like plus 5, plus 5, plus 5. It's not geometric. 8/3 is not 15/8. Whenever you see something that's plus 5, plus 7, plus 9, and what you're adding is arithmetic, that's called a quadratic sequence. And y'all know about quadratic equations, don't you? What are quadratic equations? They're like x to what? What are parabolas? Y equals?
Y equals n.
That's line. What's a parabola? We haven't talked about that formally, but do y'all know it's an x squared equation?
Y equals x squared plus 2.
So if you ever see something like this where you're like, oh wait, what I'm adding is increasing arithmetically, then that means this is some kind of squared equation. Can y'all see what I'm doing? It's not 1 squared.
It's 2 squared minus 9.
It's what? 2 squared minus 1? 3 squared minus 1? 4 squared minus 1? 5 squared minus 1? 12 squared minus 1? Right? So couldn't I say my formula is n squared minus 1? But what am I plugging in first? What did I plug in first to get a 3? What did I plug in last to get a 143? 12. Does that make sense? And that's just you eyeballing it. I don't do a lot of that on your test, but you probably see something like that on your homework tonight. All right? All right. One last one before you go. How many terms? How many terms? How many? Are there 100? No, because I didn't go 1 through 100. Stay with me, guys. It's the easiest question on your test.
97.
97. Why? Because I didn't include the what? First 3. Make sure you're reading directions tonight on this work. Y'all be going.
Church.